Stats 1 review sheet D. The first question looks a little scary to start with, but it does tell us to draw a tree diagram. So I'm going to start off by drawing a little tree diagram here. We've got a choice of either S happens, yes or no, and then R happens, yes or no. And so we've got the basic structure of the tree diagram looking like this. And we need to work on all this. I'm not even going to look at the questions yet. I'm just going to try and build the tree diagram. So this is S happening, and this is S not happening. And then R can happen, or R doesn't happen. R can happen, or R doesn't happen. And so we've got 4 events at the end here. This is S and R both happen. S happens, R doesn't. S doesn't, R does. And this one here, neither of them happen. Let's have a look at putting some probabilities on. The chance of S happening here, we're told at the start here, the chance of S happening is 0.6. So if S happens 0.6, then it doesn't happen the rest of the time, which is 0.4. Now, once S has happened, we're here. Once S has happened, does R happen? Well, yes, it does, with probability 0.5. Or it doesn't happen. That's going to be 0.5 as well, because these two add up to 1 here. Now we want what happens when S doesn't happen. That's these ones here. But R might happen with the probability 0.4, or it might not happen with the rest of the probability, which is 0.6. Still not read the questions yet. Finally, I'm going to find out what's the probability of getting down each of these branches. Down here, 0.6 times 0.5, that's 0.3. Here, 0.6 times 0.5, another 0.3. Here, 0.4 times 0.4, 0.16. And finally, 0.4 times 0.6 is near 0.24. I can check all of that by making sure that all of that adds up to 1, and it does. Finally, I can read the question. What's the probability of R happening? Well, R happens here, it doesn't happen here, and it does happen here. Put those two together, and you can see that the probability of R happening is going to be 0.46. Those two things put together. Next, the probability that S happens given that R's already happened. So we know we're at one of these two places because we know R's happened. But I want S to happen as well. So I want to be here. I want to have S and R happen. So I want my 0.3. But it's out of these two places that I was at. So it's 0.3 out of 0.46, which is 0.652. What have we got next? The probability that S doesn't happen, given that R's already happened. Well, that's just going to be the other way around, isn't it? That's wanting to be here out of we already know R's happened out of 0.46. And so that one's 0.348. Notice those two must add up to 1, because this is either S happens or it doesn't. And the last one, we've got the probability that S doesn't happen given that R happened, given that R didn't happen. So we're going to be at either here or here, because we know R didn't happen, and we really, really want to be there. So we're here, we're 0.24 out of these two together, which is 0.54, and that cancels down quite nicely into 4/9. It all stemmed from the tree diagram to start with.